Welcome all. In this lecture, we are discussing about equivalent parameters of electric drive. So, we have already discussed a simple electric drive system which consists of a motor which drives a load with a load torque TL and motor torque Tm and the speed as omega m. So, the dynamic equation of this simple motor load electric drive system is Tm equal to TL plus J d omega m by dt. So if it is a simple system with single load, we can use this equation, governing equation, to find the or analysis the motor load system. So next consider a motor load system with a number of rotational motion loads. So here there are two loads, TL0 and TL1 loads. Okay, the loads are having the load torque TL0 and TL1. So the case of TL0 torque load is it is directly coupled to the motor, means the this load is rotating with the same speed that of motor, but this load, the second load with the load torque TL1 is coupled to the motor through a gear. Okay, with a gear tooth N here and N1 here. So the speed will be changing from omega m to omega m1 depending upon the number of tooth in the gear. So this has two loads. Okay, so it's a complex drive system. So if we can find an equivalent system with single load which is equivalent to these two loads, we can directly apply the this equation. So in this session we are aiming at to find the equivalent load torque and equivalent J, moment of inertia, to convert this complex system to a simple motor load system. So this load will be equivalent to these two loads. Okay, in that way we are deriving the equation for TL equivalent and J equivalent. Okay. So consider the complex system. So to find the effective moment of inertia, we are equating the kinetic energy. So the kinetic energy of this system will be the kinetic energy of this and this. So here the J0 is the moment of inertia of motor plus this load. Okay, this is the moment of inertia of both this motor load, this directly coupled load and motor. It is sum of the moment of inertia of motor and load. And J1 is the moment of inertia of this single load only. Okay, so the kinetic energy will be equal to, for this it is half J omega m square, so half J0 omega m square for this motor and load, and for this it is J1, so J1 and the speed is omega m1. Okay, because of the gear the speed will be converted into omega m1. Okay, so it is J1 omega m1 square. So total kinetic energy related to this complex system will be equal to sum of this moment of inertia. So half sum of this kinetic energy. So half J0 omega m square plus half J1 omega m1 square. And if you are considering the equivalent single load system, the effective system, it will be equal to half J effective omega m square, for where J effective is the effective moment of inertia of these loads. Okay, this equivalent single load. Okay, so we can equate these two kinetic energies. So we'll be getting as half J effective omega m square equal to half J0 omega m square plus half J1 omega m1 square. Okay, so again we can divide this by omega m square and half. Okay, so it will be equal to J effective is equal to J0 plus J1 omega m1 square divided by J omega m2 square, and omega m is the speed of motor. Okay, and omega m1 is depending upon this gear ratio. Okay, so it is equal to omega m1 by omega m equal to n by n1. Okay, so n is the number of teeth in this gear and n1 is number of teeth in this gear. Okay, so let that ratio is equal to a1, n by n1 is a1. So we can find we can write the effective moment of inertia as J effective is equal to J0 plus J1 A1 square. Okay, So this is the effective moment of inertia of this complex system. Okay. And if there are number of loads coupled by the gears, it will be J effective equal J0 plus J1 A1 square, for next J2 A2 square, J2 for J3 A3 square, etc., etc. Okay, up to n system. Okay, so that is the case. And in order to find so now we got J effective. So next we have to go find the TL effective. Okay, effective load torque. For that we can equate the powers. For find the first the power of this will be equal to actually power is T omega. Okay, so for this case it is TL0 omega m, and for this case there is a gear arrangement here. So if eta 1 is the efficiency of this gear transmission, the power here is will be equal to TL1 omega m1 divided by eta 1. Okay, so the motor has to power according to this efficiency also. Okay, so this plus this, so TL0 omega m plus TL1 omega m1 by eta 1. Again for equivalent system it will be TL effective omega m, T omega. Okay, so if you equate to the power, we will get TL effective omega m is equal to TL0 omega m plus TL1 omega m1 by eta 1, or we can write TL effective as TL0 plus TL1 by eta 1 into omega m1 by omega m. Again omega m1 by omega m is equal to A1. Okay, so we can write TL effective is equal to TL0 plus TL1 by eta 1 A1, where eta 1 is the efficiency of this gear transmission. Okay, it will involve the friction of tooths and everything. Okay, again if there are number of loads, we can write TL0 plus TL1 by eta 1 A1 plus TL2 by eta 2 A2, etc., etc. Okay, so now we have got the effective TL and J effective. So we can simply apply the basic equation Tm equal to TL plus J d omega m by dt, where TL effective and J effective should be applied. Okay, so TL effective is TL0 plus TL1 by eta 1 A1, and J effective is J0 plus J1 A1 square. So now we can analyze the complex drive system by this basic simple dynamic equation of electric drive.